Good morning, afternoon, or evening, cats and dogs. Today's video comes from the lesson 8.7 guided notes on solving one-step inequalities. So let's start off by comparing solving equations to solving inequalities. We're going to start off with some one-step equations by adding and subtracting. So let's take a look at this equation on the left, number 1. X minus 8 equals negative 12. We know that what's happening to the variable is we're subtracting by 8, but the inverse of that is to add by 8. So we would add 8 on both sides, and that would get us x equals negative 4. Let's go over to the right. We have the same situation, we have the same scenario, but it is an inequality. So we have x minus 8 is greater than negative 12. We're going to solve inequalities the same as we solve equations using those same inverse operations. So if what's happening to the variable is we're subtracting by 8, then we're going to add 8 to both sides. The only difference is for our final solution, we're going to have x is greater than negative 4. We want to make sure to have that inequality symbol rather than the equal sign. So let's take a look at number 2 on the left underneath the equations. We have x plus 6 equals negative 21. The inverse of adding by 6 is to subtract by 6. Negative 21 minus 6, be careful with that calculation, that is negative 27. So we get x equals negative 27. We're going to solve our inequality the exact same way. Again, those inverse operations. We're going to subtract 6 from both sides. We get x is greater than or equal to negative 27. So we solve our equations the same way as we do inequalities and vice versa. The one difference with inequalities is we don't just have one solution, we have an infinite number of solutions. So the solution to this inequality is x is greater than negative 4, meaning that any number greater than negative 4, like negative 3.5, negative 3, negative 2, 0, 1, a million, all of those numbers will make this inequality true. And number 2, all numbers greater than or equal to negative 27, including negative 27, will make this inequality true. So a way to check it would be to choose a value that makes the inequality true, see if it also makes your original inequality true. All right, let's try some practice. Like I said before, it's not a bad idea for if you want to try some of these on your own to do that. I would just double check either with the video or, of course, if you're in the live session, you'll get that information as well. So we're going to solve these and we're going to graph our solution set on a number line like we did in our 8.6 guided notes. So number 1, when we have g minus 5 is less than negative 8, the inverse of subtracting by 5 is to add 5. So we'll do that to both sides. That will get us g is less than negative 8 plus 5, which is negative 3. Just bring that inequality symbol straight down. Now when we go to graph this, 3 tick marks, a minimum of 3 numbers, although you can have more. I'm going to put negative 3 in the center. Negative 4 is smaller. That'll go to the left. Negative 2 is bigger. It will go to the right. This will be an open circle at negative 3 because it's less than and not equal to. If it has an equal to sign, then we know that would be a closed circle. And since we're talking about g is less than negative 3, we are going to shade to the left. So let's go ahead and do that. So shade to the left for less than. Remember that less than symbol looks a little bit like an L. All right, let's take a look at number 2. Now the variable's on the right-hand side, so at the end we'll rewrite it with the variable on the left instead of on the right. The inverse of adding by 8 is to subtract 8. Negative 9 minus 8 is negative 17. You're going to notice that I get negative 17 is greater than or equal to t. If you write that as your solution, that's fine. But I do suggest rewriting it with the variable on the left for when you go to graph it. So both solutions are equivalent, and I would accept both. But I like to rewrite it as t is less than or equal to negative 17. Flip the variable to the left, the number to the right, and flip that symbol as well. So I'm going to put negative 17 in the center, negative 18 to the left, negative 16 to the right. Watch the order of those numbers. This one is equal to, so it's a closed circle. Since it's less than or equal to, we are going to shade to the left. So let's go ahead and do that. There we go. All right, let's take a look at number 3. And we're going to move through these quickly because this is the same as when you solve one-step equations as well. So we have negative 12 plus m is greater than negative 14. The inverse of adding by negative 12 is to add a positive 12 to both sides. That will get us m is greater than negative 14 plus 12, which is negative 2. So put my negative 2 in the center, negative 3 to the left. Again, smaller always goes to the left. Negative 1 is bigger, it goes to the right. This one's going to be an open circle. Let's make that a little bigger. There we go. open circle, but since it's greater than in this case, we're going to be shading to the right for this problem. We really want to be careful and make sure we're shading the correct direction, because that's definitely part of the points when you do these on a test or a quiz. All right, let's move ahead to numbers 4, 5, and 6. If you need to pause the video at any time because you fall behind, no big deal. In number 4, n minus negative 15 is greater than or equal to negative 24, I do suggest rewriting that as n plus 15 is greater than or equal to negative 24. The inverse of adding by 15 is to subtract by 15. Double check all these things in your calculators because negative 24 minus 15 is negative 39. Go ahead and pull this down. All right, negative 39 is going to go in the center, negative 40 to the left, negative 38 to the right. This one is a closed circle. Again, that equal to sign underneath tells us it's closed. Greater than or equal to means I'm going to shade to the right. Get some Apache in our head, right? So we're going to go ahead and shade to the right for this one. All right, number 5. Variables on the right again. We will rewrite it with the variable on the left. Some students ask me, can I do that at the beginning? Absolutely. Just make sure you flip everything around. But it will say r minus 54 is greater than 29. Of course, the inverse of subtracting by 54 is to add 54. 29 plus 54 is 83. So I get 83 is less than r. Flip the variable to the left, the number to the right, flip the symbol as well. So final solution, r is greater than 83. So 83 is going to go in the center. Watch the positives. I feel like sometimes we see so many negatives, negative numbers on the number line that students graph those right and then graph the positives wrong. Smallest on the left, biggest on the right, 82, 83, 84. This will be an open circle since it's not equal to, and again, since it's greater than, and remember, you can make this symbol into an arrow that points to the right, and that's the direction we're going to shade, to the right. You've got to have an understanding of these symbols for sure. So let's go ahead and shade to the right. All right, next one, number 6. Mixing in some decimals as well, we might as well get that practice. Negative 9.1 is greater than or equal to p plus 8.6. The inverse of adding 8.6 is to subtract 8.6. Negative 9.1 minus 8.6 is negative 17.7. And again, I do suggest rewriting it with the variable on the left. So notice how the pointed part is still facing the p in both of these. If you want to think of the mouth of the alligator or crocodile facing the number, negative 17.7, that's fine too. Now the way I do suggest graphing this is I'm going to put negative 17.7 in the middle. I'm going to put negative 17.8 to the left, negative 17.6 to the right. Could you do negative 17.7 in the middle, negative 18.7 to the left, negative 16.7 to the right? Sure, there's other ways to graph these. I've even seen students just make 2 tick marks and then just kind of estimate where negative 17.7 is. So there's not really a one right way to do these problems when you go to graph them on the number line. Now regardless, you're going to have a closed circle at negative 17.7, and because it's less than or equal to, you're going to be shading to the left. So the open and closed circle and direction you shade doesn't change, but how you set up your numbers might be a little different, just depending on what you choose. Just make sure you count evenly, of course. All right, let's mix in some more decimals and then a couple of fractions as well. So number 7, we have y minus 14.8 is less than negative 12.6. The inverse of subtracting by 14.8 is to add 14.8. Have those calculators handy and double check. Negative 12.6 plus 14.8 gets us 2.2. So we end up with y is less than 2.2. Let me circle that solution. So we get y is less than 2.2. I'm going to put 2.2 in the center, 2.1 to the left, and 2.3 to the right. I have seen students do 1.2, 2.2, 3.2. That's okay as well. Because this is not equal to, it is going to be an open circle, and since it's less than, we are going to shade to the left. So let's go ahead and do that. There we go. All right, number 8, mix in those mixed numbers. G plus 1 1/3 is greater than or equal to negative 2 3/4. So we will subtract 1 1/3 from both sides. Negative 2 3/4 minus 1 1/3. Again, practice plugging these into your calculators. It's going to get us G is greater than or equal to negative 4 1/12. So the way I chose to do this was I put negative 4 and 1/12 in the center, negative 4 and 2/12 to the left, and negative 4 to the right. Now, that's negative 4 and 0/12. I've also seen students do negative 4 and 1/12 in the center, negative 5 and 1/12 to the left, negative 3 and 1/12 to the right. That's okay as well. Again, we're very open here to different ways to set up your number lines as long as you count evenly. This is going to have a closed circle in this case because it is equal to, and greater than or equal to means we are going to shade to the right. So let me go ahead and get my graph ready to go. There we go. All right, let's take a look at number 9. It's going to be the last one, I believe, from this section before we see one-step inequalities by multiplying and dividing. So number 9, we have negative 2 and 4/5 is less than x minus 3 and 1/4. So we're going to add 3 and 1/4 to both sides. And that's going to get us 9/20 is less than x. Let me have my line in here underneath. There we go. So we're going to get negative 2 and 4/5 plus 3 and 1/4, which is 9/20 is less than x. I do like to rewrite it with the variable on the left. So it's x is greater than 9/20. So I chose 8/20, 9/20, and 10/20. And yes, 8/20 and 10/20 do reduce and simplify, so you can certainly do that if you choose. This one's definitely going to be an open circle because it's greater than and not equal to. So we are going to shade to the right. Again, you need to know less than you shade to the left, greater than you shade to the right. That only works, though, again, if the variable's on the left. Sometimes students see in this solution right here, 9/20 is less than x, and they're like, oh, I've got to shade to the left. But it's really that your solutions are greater than 9/20, so those are numbers to the right. All right, I did throw some independent practice in here as well, so why don't you pause the video, give these two questions a try, solving and graphing them. When you're ready, restart the video, and we'll take a look at these two problems. All right, so hopefully you've got these two done. Number 1, you want to subtract 19 from both sides. That's going to get us x is less than negative 30. You should have an open circle shaded to the left. Number 2, for this one, the inverse of subtracting by 15 is add 15. So you get negative 8 is less than or equal to x, or x is greater than or equal to negative 8. This one's a closed circle, though, because it's equal to, and greater than or equal to means we shade to the right. So make sure you've shaded the correct direction. All right, so the next thing we want to do is do one-step inequalities by multiplying and dividing. So let's compare equations to inequalities again. If I have 8x equals 24, it's 8 times x. The inverse is to divide by 8. So we'll divide both sides by 8 to get x equals 3. Guess what? We do that the same for the inequality. Divide both sides by 8, except we get x is greater than 3 here, not just x equals 3. For number 2, we have x over 6. Fraction bar represents division, so we're going to multiply both sides by 6. Gets us x equals negative 30. And not surprisingly, on the right-hand side here, we're going to multiply both sides by 6, and we get x is greater than or equal to negative 30. But wait a minute. Let's take a look at this one. Negative 5x is less than 25. The inverse of multiplying by negative 5 is not to add 5, but to divide by negative 5. That gets me x is less than negative 5. This means that all numbers less than negative 5 are solutions. But if I check it with a number that's less than negative 5, like negative 6, I get a false statement. Like negative 5 times negative 6 is positive 30. That isn't less than 25. Is negative 10 a solution? Well, if I take negative 5 times negative 10, I get positive 50. That's not less than 25. So I get something that's not true. So someone at some point in time recognized that any time you multiply or divide both sides of an inequality by a negative number when you go to solve, which we didn't see in our last two questions from the previous slide. We didn't obviously do this when we did adding and subtracting. But if you multiply or divide both sides of an inequality by a negative number, you must switch the inequality symbol around so it points the opposite direction. Otherwise, you're going to have the opposite of what the solutions are. You're going to get numbers that are not solutions to your inequality. So instead of writing our solution as x is less than negative 5, we flip only the inequality, and we rewrite it as x is greater than -5. So numbers like -4, -3, -2, 0, 1, 2, etc. will make this inequality true. For example, 2 is greater than -5. -5 times 2 is -10. That is indeed less than 25. So numbers that are greater than -5 do make this true, but that only works if we flip our inequality symbol around, again, because we're multiplying or dividing by a negative. So let's take a look at question number 2 here. So we've got x over -7 is greater than or equal to -9. The inverse of dividing by -7 is to multiply by -7. But if you multiply both sides by a negative, you have to flip the inequality symbol around. So our final solution is going to be x is less than or equal to positive 63. Don't forget, a negative times a negative is a positive. In our second example here, number 3, -12x is greater than 144. The inverse of multiplying by -12 is to divide by -12. That's going to get us x is less than -12 for our final solution. Again, we switch that symbol around because we divided both sides by a negative. These are things that are definitely important for us. It's going to be easy to forget this, so just kind of try to keep that in the back of your mind that sometimes you might have to flip the inequality symbol. So we're going to be mixing in different kinds of questions with numbers 10 through 21. Again, if you feel comfortable and you want to try some of these on your own, feel free to do that. Just double check using the video to make sure that your solutions are correct. So in number 10, we have 5g is less than -45. The inverse multiplying by 5 is to divide by 5. We do not need to flip the inequality symbol around here because we divided by a positive 5. My answer is going to be negative, so sometimes I have students who think, well, my answer is negative, it means I need to flip my symbol around. But I divided by a positive 5, I don't flip it. So I get g is less than -9. Put -9 in the center, -10 to the left, -8 to the right. Just like before, this is going to have an open circle here, so put an open circle at -9. And less than means we're going to shade to the left. So let's go ahead and do that. It's going to look like this. There we go. Number 11. So number 11 I think is actually one of the hardest of these because the variable's on the right and we are going to have to flip the symbol too because the inverse of dividing by -11 is to multiply by -11. -9 times -11 is 99. Notice how, and I'm going to highlight this in yellow, from here to here, my inequality symbol flipped around because I multiplied by a -11. And of course, we have t on the right-hand side as well. Now, I do still suggest rewriting it with the variable on the left. So move the t to the left, the 99 to the right, flip the symbol as well. So know that this answer right here that I have the green dot next to and the answer that I'm going to highlight in green here, those are equivalent to each other. You might think, well, why am I flipping the symbol back? But I'm flipping everything else around too, so it keeps the meaning the same. Whereas from the yellow dot to the other yellow dot, I flipped only the symbol, which did change the meaning. So I'm going to graph t is greater than or equal to 99. So I have 98, 99, 100. This one is going to be a closed circle since we have that equal to sign there. And greater than or equal to means I'm going to shade to the right. There we go. All right, number 12, let's take a look at this one. -4m is greater than -16. The inverse of multiplying by -4 is to divide by -4. We will flip the symbol around and just the symbol because we divided by a negative. So we get m is less than, watch that sign, +4. All right, let's put our numbers here. 3 on the left, 4 in the center, 5 in the right. Whoops, don't want to move that. That's a problem. All right, open circle at 4. Since it's m is less than 4, we're going to shade to the left. All right. Moving right along, let's take a look at numbers 13, 14, and 15. So number 13, we have n over 8 is greater than or equal to -5. The inverse of dividing by 8 is to multiply by 8. That's going to get us n is greater than or equal to, no need to flip anything around, -40. We multiplied both sides by a +8. So -40 will go in the center, -41 to the left, -39 to the right. This one's going to have a closed circle since it's greater than or equal to, and of course, it's greater than or equal to, so we are going to shade to the right. It's a lot of examples. So again, if you feel like you want to try some of these on your own, go ahead and do that. Now, numbers 14 and 15 have something a little different with each of these. You don't have the negative sign either with the R or the 8, but you can put it with either number if you have a negative in the center of a fraction. So I suggest rewriting this as 3 is less than R over negative 8. You don't want to put that negative with the variable because that's what you're trying to solve for. Now we'll multiply both sides by negative 8, which means we need to flip the symbol. We do that again from here to here since we multiplied by a negative. So we get negative 24 is greater than R. I do suggest rewriting it with the variable on the left, which is R is less than negative 24. So be careful with this one. I don't think you have anything like this on your test if I can remember correctly, but it's not bad for us to take a look at these kind of problems as well. So we're going to have an open circle for this one at negative 24. Final solution is R is less than negative 24, so we are going to shade to the left. All right, so number 15 is really similar to number 14. I'm going to move that that negative sign with the 4 instead of with the P. And then I'm going to multiply both sides by negative 4, which means we need to flip our inequality symbol around, again, from here to here. Negative 5 times negative 4 is positive 20. And we're going to be left with P on the right-hand side. I do suggest rewriting it with the variable on the left, so you get P is greater than or equal to 20. So we're going to put 19, 20, 21 here. This one, oops, looks like we're missing a circle, so we need a closed circle. Let me copy this guy over. So we're going to have a closed circle at 20, and greater than or equal to means I'm going to be shading to the right. All right, 16, 17, 18, let's take a look at these as well. All right, for number 16, the inverse of dividing by negative 4.8 is to multiply by negative 4.8. We're going to flip that symbol around because we multiplied both sides by a negative, so we get y is greater than 14.4. We've got 14.3 on the left, 14.4 in the center, 14.5 on the right. This is going to be an open circle since it's not equal to, and it's greater than, so we shade to the right. So this should be becoming pretty routine for you at this point. Again, it's maybe a little overkill for the number of examples we have, but I do think it benefits us. Number 17, the inverse of multiplying by 25 is to divide both sides by 25. So let's do that. Now I divided by a positive, so no need to flip my symbol around. I get W is greater than negative 8. So on my number line, I've got negative 8 in the center, negative 9 to the left, negative 7 to the right. This one's going to have an open circle since it's greater than and not equal to. And since it's greater than, we are going to shade to the right. Just like this. There we go. Number 18, the inverse of dividing by 2.1 is multiplying by 2.1. No need to flip it since we are multiplying both sides by a positive. So we get y is less than or equal to negative 16.8. For this one, we're going to put negative 16.8 in the center. This is not the only way to count for the decimals, just like we did for the one step by adding and subtracting. I'm going to put negative 16.9 to the left, negative 16.8 to the right. Closed circle in this case, less than or equal to, we shade to the left. All right, last 3 of these, and then we do mix in some one step by add and subtract with multiplication and division here. So let's move through these pretty quickly. Number 19, negative 1/2 b is greater than negative 6. The inverse of multiplying by negative 1/2 is to divide by negative 1/2. Since we did divide both sides by a negative, we're going to flip that symbol around and get b is less than 12. Remember when we divide by a half, it's the same as multiplying by 2. So from left to right, we've got 11, 12, 13. This one's going to have an open circle, and since it is less than, we are going to shade to the left. All right, let's take a look at question number 20. We've got 2 1/3 r is less than 3 1/2. The inverse multiplying by 2 1/3 is to divide by 2 1/3. Since we're dividing by a positive, no need to flip the symbol. You should get r is less than negative 1 1/2. So I'm going to put negative 1 1/2 in the center, negative 2 to the left, negative 1 to the right. This one's going to have an open circle since it's not equal to, and less than means we shade to the left. All right, number 21. So for this one, we have negative 7 is greater than or equal to a over negative 3.4. Let's multiply both sides by negative 3.4. Negative 7 times negative 3.4 is 23.8, but notice that I flipped my inequality symbol around from here to here since we multiplied both sides by a negative, and then I did rewrite it with the variable on the left. A is greater than or equal to 23.8. So I've got 23.7 on the left, 23.8 in the middle, 23.9 on the right, close circle, and since it's greater than or equal to, we are going to shade to the right. All right, I do also have some independent practice on these for you to try. You've already seen a lot of practice problems, so if you're like, I don't feel like I need it, as advanced students, you can skip them. But we definitely want to finish up this video with numbers 22 through 26. So here's your independent practice. Feel free to pause the video, give them a try, and when you're ready, go ahead and start the video again. Notice how you do not need to graph these inequalities, just solve them. All right, so let's take a look at these. Beginning with number 1, we've got to divide both sides by 12. No need to flip anything around. You get x is greater than or equal to negative 5. Number 2, we're going to multiply both sides by negative 3, but we do need to flip the symbol because we multiplied by a negative. So you're going to get x is greater than 63. Finally, number 3, let's take a look at this one. We're going to divide both sides by 7. So we've got negative 8 is less than or equal to x. Did not flip the symbol here since I divided by a positive, but I did rewrite it with the variable on the left. That being said, if you put this highlighted solution as your answer, you're also correct. You will not lose points for putting that. All right, so our last 5 examples, 22 through 26. Let's get through these. We're not graphing them. We're just solving these one-step inequalities. Let's talk about number 22. The inverse of adding negative 2 2/3 is to add a positive 2 2/3 to both sides. So in your calculators, you're doing negative 6 1/2 plus 2 2/3. You should get b is greater than negative 3 5/6. Number 23. The inverse of multiplying by negative 7, remember, think through what's happening to the variable, is to divide by negative 7. You do need to flip the symbol here, though, because you're dividing by a negative. So you get m is greater than or equal to negative 4. Number 24, negative 29 is less than d minus 84. The inverse of subtracting 84 is to add 84. Negative 29 plus 84 is 55, so we get 55 is less than d. You can also write it as d is greater than 55, but I would accept either of those solutions. All right, last 2. T over 1.2 is less than negative 4.5. The inverse of dividing by 1.2 is to multiply by 1.2. That will get us t is less than, don't flip anything around here, negative 5.4. Finally, negative 1 1/2 b is greater than or equal to 9. The inverse of multiplying by negative 1 1/2 is to divide by negative 1 1/2. 9 divided by negative 1 1/2. We're going to flip that symbol around since we divided both sides by a negative. That will get us b is less than or equal to negative 6. We're going to pick up where we left off in the lesson 8.7 guided notes with question number 27. Before that, though, we do have a box that I want to talk about. We're going to be doing some one-step inequality word problems here. We're going to complete numbers 27 through 33. I'm not going to look at numbers 34, 35, 36, 37, or 38 in these guided notes. Well, they're not bad questions. They're not ones that you necessarily need for the test. In fact, some of the things are going to come up a little bit later, and numbers 35 and 36, we talk about the triangle inequality theorem. That's going to come up later on this year anyway, so it's not a big deal for us to skip some of those. We definitely need to see these word problems, though. So we have some steps to writing inequalities to solve problems. The first step is always to identify your unknown, of course. I don't have that stated here, but we want to start with that. Then identify what key word or phrase represents our inequality. Sometimes it's going to be pretty obvious. We might say at least, maximum, minimum. Other times it might not be as obvious. You will write your inequality symbol, and a lot of times there's going to be a number that follows that phrase that represents your inequality symbol, so that number will come right after your inequality symbol. Now, an exception to this is if a problem says he or she has this much to spend, or he or she has a certain amount of money, then we're going to use the less than or equal to symbol. This is going to come up in question number 28 when we see it. It's also going to come up in question number 32. So we are going to see that a lot, where we might say Jessica has $50 to spend. We know that she wants to spend less than or equal to that amount of money. We also want to determine if this is an addition-subtraction situation or multiplication-division. The good news with our two-step inequalities that we'll eventually get to, we're going to have both addition, subtraction, and multiplication-division in it, so you don't have to make that determination. A lot of times it's going to be pretty obvious. You might have some other words or phrases that represent operations as well. Like a lot of times we see the word per, which means to multiply, to help us write our inequality. Now I know when we did equations, a lot of you solved your equation when you wrote it. So you may have said, for example, $337.50 divided by $13.50 equals H. We're actually going to see those numbers in a problem today. That's great for your equations, but inequalities, we have to have an inequality symbol between those. So you really want to be careful and make sure inequality symbol makes sense. You will solve your inequality, of course, just like we did before with one-step inequalities, and I will ask you to interpret your solution, which means to explain what your solution means for the problem. So just a sentence. It doesn't have to be a really long essay or paragraph, just a sentence. Please also make sure your answer makes sense. Make sure it's reasonable as well. Sometimes students write the wrong inequality, and then when they get to their final solution, they're like, oh, wait a minute, this doesn't make sense. Maybe I need to flip my inequality symbol around. So you might see that at times. Also, if you choose to use addition or subtraction when it's a multiplication-division situation, you might also get an answer that doesn't make a lot of sense. So let's take a look at number 27. Antonio has at most $18 to ride go-karts and play games at the state fair. The go-karts cost $5.50. A. Write an inequality that can be used to determine how much he can spend on games. So first off, we are trying to determine how much he can spend on games. So I did define a variable to represent that. I chose the variable g for the amount he can spend on games. We also want to identify what key word or phrase represents our inequality. So reread the first couple of sentences again. What phrase represents our inequality? Hopefully you said at most. So at most is going to be what inequality symbol? Less than or equal to. And in fact, it says at most $18. So I know that 1/2 of my inequality is going to be less than or equal to 18. Now, we know that G represents the amount he can spend on games, and we know that he's also going to go on the go-karts or use the go-karts, and they cost $5.50. So if G represents the amount he can spend on games, he spent $5.50 on go-karts. What are we going to do with those numbers? We really have 4 options here. You can add G and 550, you can multiply them, you can subtract them, or you can divide them. Think about what makes sense. If you're thinking we should add them, you are correct. Now, if you were thinking subtracting, that's okay too, because we would really subtract to find our solution. We want to take the amount spent on games plus the amount he spent on go-karts, $5.50, and we want the total amount spent to be less than or equal to 18. Now, you could write G is less than or equal to 18 minus $5.50. That's acceptable as well. Let's go ahead and solve this. So as I said, the inverse of adding is to subtract. So let's subtract $5.50 from both sides. That's going to get us G is less than or equal to $12.50. So when we interpret our solution or explain what it means, we have to use some sort of phrase that represents our inequality. And I like to use the phrase that's given in the problem, at most. So what I will say is that Antonio can spend, at most, $12.50 on games, since he needs to spend less than or equal to $12.50 on games. All right, let's take a look at our next word problem. Number 28. Quentin has to pay 50 cents every time he plays his favorite video game. Quentin has $20. Write and solve an inequality to determine how many times Quentin can play the video game. Interpret your solution. So maybe he's got some sort of arcade game in his basement. We are trying to determine how many times Quentin can play the video game. So I chose the variable t for the number of times he can play the video game. Now there is no word or phrase like at most in this one that tells us what inequality symbol to use, but we do know that Quentin has $20. And as we said a couple of slides ago, if we know that someone has a certain amount of money, we want them to spend less than or equal to that amount. We also know that Quentin has to pay 50 cents every time. Keep in mind, t represents the number of times he plays his favorite video game. So think about what makes sense. Do we add t and 50 cents? Do we subtract? Do we multiply or divide? If you're thinking multiply, you're correct. We want to take 50 cents times the number of times he plays the video game, and we want that to be less than or equal to $20. If it ever says for each, for every, or per time, we're probably going to multiply those things. Now you could also write t is less than or equal to 20 divided by 0.5. That would work also. In fact, we solve this by dividing. So let's divide both sides by 0.50. That's going to get us t is less than or equal to 40 times. So what does this mean for Quentin? Well, it means that he can play the video game at most 40 times, up to 40 times, a maximum of 40 times. Just make sure you use some sort of phrase in your explanation that describes our inequality. You could even say Quentin can play the video game less than or equal to 40 times. But I think at most, or a maximum of, or up to 40 times is sufficient as well. All right, number 29. David earns $13.50 per hour. Write and solve an inequality that can be used to determine how many hours David must work if he wants to earn at least $337.50. Interpret your solution. So we are trying to determine how many hours David must work if he wants to earn at least $337.50. So I define my variable h to represent the number of hours. There is a phrase that represents our inequality here. What is it? If you were thinking at least, you are correct. So at least is greater than or equal to. So we want to have greater than or equal to $337.50. We also know that David earns $13.50 per hour. Keep in mind h represents the number of hours. So what makes sense for how we can write this? If you're thinking $13.50 times h is greater than or equal to $337.50, you are correct. It says per hour. That generally is going to mean multiplication. Now we're going to divide to find our solution. So we're going to take $337.50 divided by $13.50, and we will get h is greater than or equal to 25 hours. So let's interpret our solution. What does this mean for David? I like to use the same phrase from the problem, at least. So let's say that David must work at least 25 hours. All right, we have 4 more, so let's take a look at these. These should be starting to get to be a little bit more routine. Numbers 30 and 31 are pretty similar. 32 and 33, I'm going to suggest you maybe try those on your own, and then we will take a look at those once you've restarted the video. But let's do numbers 30 and 31 together. If you want to pause it and try them on your own, you're more than welcome to do so. Number 30, a bridge has a maximum weight capacity of 2,500 pounds. If there are 2 cars on the bridge totaling 1,250 pounds, write and solve an inequality to determine how much weight the bridge can still hold. Interpret your solution. So I sometimes have students who try to figure out how many cars the bridge can still hold. We're just looking at how many more pounds the bridge can still hold. So we are trying to determine how much weight the bridge can still hold. So I chose the variable W to represent the amount of weight the bridge can still hold. Now, what word or phrase represents our inequality here? If you're thinking maximum, yeah, that makes sense. That's correct. And it's a maximum of 2,500. So this bridge has to hold less than or equal to 2,500 pounds. Now, W represents the additional weight the bridge can still hold, but we already have 1,250 pounds on this bridge. So how can I set this up? Think about what I'm going to do with the 1,250 and the W. Add, subtract, multiply, or divide. If you're thinking to add them, that makes sense here. We want to take the 1,250 pounds we already have on the bridge, plus the W more pounds that we're going to add on, and of course we want that total to be less than or equal to 2,500. Let's subtract 1,250 from both sides. That's going to get us that W is less than or equal to 1,250 pounds. So we can probably pretty much double the weight on the bridge, maybe 2 more cars about on the bridge, so we don't go over our limit. Let's interpret this. We can say that the bridge can still hold a maximum of 1,250 pounds. I like to use the words or phrase from the problem that are given. In this case, it's maximum. Might as well use that phrasing again. All right, moving right along. Number 31. Carla is saving money to buy a new iPhone. She has $95, but her goal is to save at least $350. Write and solve an inequality to determine the least amount of money that Carla still needs to save. Interpret your solution. So in this question, we are trying to determine the least amount of money Carla still needs to save. This is very similar to our last question because we were trying to figure out how much weight the bridge could still hold. So when I defined my variable, I said M represents the amount of money that Carla still needs to save. What word or phrase is going to represent our inequality symbol? If you were thinking at least, you're correct. She wants to save at least $350, so she wants to save greater than or equal to $350. We know that she has $95. She's going to save M more dollars, or can save M more dollars. And again, she wants to have a total that is greater than or equal to $350. What makes sense here? If you were thinking to add M and 95, that makes sense. Now again, if you're thinking subtraction, that's how we solve this. Addition and subtraction are inverse operations. So you're not completely wrong, but if we have M and 95, the operation that has to go between them is addition. So we have M plus 95 is greater than or equal to 350. Let's solve this. Subtract 95 from both sides. We should get M is greater than or equal to 255. So this means for Carla that she still needs to save at least $255. Now, I have had students set this up as M minus 95 is greater than or equal to, I'm going to type it like this, 350. They add 95 to both sides, and that's going to get us 445. If we say that she still needs to save at least $445, that doesn't make sense. If she wants to earn $350 as her minimum, she definitely doesn't still have to earn or save an additional $445. So if you set it up wrong and you use the wrong operation, you're probably going to get something that isn't reasonable or doesn't make sense for the situation. So that's the other reason why we do interpret this, to see if it makes sense. All right, so as I said before, it does say to try these on your own. You may want to pause the video, give these 2 questions a try, and when you're ready, restart the video and we'll take a look at these 2 questions and their solutions. All right, so number 32, Gabriella went to the movie theater with her friends. She had $20 to spend. The movie ticket cost $7.25. Write and solve an inequality that can be used to determine how much she had to spend on snacks. All right, so in this situation, hopefully you've taken a look at this already, we are trying to determine how much she had to spend on snacks. So I chose the variable S for the amount she can spend on snacks. There is not a word or phrase that represents our inequality symbol, but we know that she has $20 to spend. So we want her to spend less than or equal to $20. We know that the movie ticket cost $7.25. She's going to spend S on snacks. Think about what makes sense. If you go to the movies, are you going to add, subtract, multiply, divide your snacks to your ticket? What makes sense here? If you were thinking to add them, take your snacks plus your ticket cost to be less than or equal to $20. You are correct. Let's go ahead and solve this by subtracting $7.25 from both sides. We're going to get that S is less than or equal to $12.75. For Gabriella, this means that she can spend a maximum of or up to $12.75 on snacks. All right, last question. Number 33, a Major League Baseball pitching coach tries to limit his pitchers to 110 pitches per game. If the pitcher has already thrown 45 pitches, write and solve an inequality that can be used to determine how many more pitches the pitcher can throw. That's a tongue twister. All right, we want to determine how many more pitches the pitcher can throw. Oops, I got a little loopy-loop going on there. So I chose the variable P for the number of pitches the pitcher can still throw. We do have a word in this case that represents our inequality. It's the word limit. So we know, and it's a limit of 110 pitches, that we want this pitcher to be able to throw less than or equal to 110 pitches total. We know the pitcher has already thrown 45 pitches. So think about what you would do with the 45 and the P. Add, subtract, multiply, or divide. If you were thinking add, that makes sense. Take the 45 he or she has already thrown, plus P more pitches. We want that total to be less than or equal to 110. All right, let's go ahead and solve this. So we are going to subtract 45 from both sides and get P is less than or equal to 65 pitches. So for the pitcher, this means that the pitcher can throw a limit of 65 more pitches. Thanks for listening.